This is the second part of the introduction. Okay, so this perceptual process. What are the basic processes of perception? Well, we're going to start, again, it's going to be described in this very bottom-up fashion. I'm going to start with the stimulus, and I'm going to distinguish between the distal stimulus and the proximal stimulus. The distal stimulus being the environmental stimuli, whatever is actually out in the environment. So in this case, the angel tree. I've left in here the attended stimulus is important, and it can influence the proximal stimulus. It can influence, it's unclear exactly where it influences, and so he took it out, but it's important that it can influence the proximal stimulus. So right now, if you're doing something else and you're not attending to what I'm saying, there's still some proximal stimulus because it's sound and it's hitting your ears and you can't stop that. But if you're actually looking at the angel tree, that in this case will be the distal stimulus, and because you're attending to it, it'll be the proximal stimulus. So for vision, it really kind of works that part of how we're getting the proximal stimulus is by attending to something specific. If you guys might want to write down if you want to ask questions about that, because I do kind of blather my way through that now. He took it out. I still think it's kind of important to know that attention is important for all of this, but the proximal stimulus is really different. It's the stimulus still, but it's the stimulus on the receptors themselves. So this is some image or representation of the stimulus. And throughout this example, I'm going to use vision. I'm going to use this picture of the angel tree. And so if you're looking at that angel tree right now, that image is hitting your photoreceptors in your eyes, and it is an inverted upside down image. Okay, it's flipped on the photoreceptors because of the optics of the eyeball itself. Those photoreceptors are receiving this inverted upside down image, and nobody took that tree or that picture in this case and shoved it into your eye, right? So now we have an image, and it is a representation of the stimulus, which is really clear in the fact that it is inverted and upside down. That representation has gone through transformation, and it is a representation. So here we talk about the principle of transformation, that we're transforming the stimulus out in the environment, the actual tree, into the light that's being reflected from it and then hitting the photoreceptors, and it is being represented. That's what's happening at the photoreceptors, and that's the proximal stimulus. He used to pull these out into the stimulus and then electricity and so forth, and I do find that useful for conceptualizing it, but I don't think he does that anymore. So before that was the stimulus, and now we're going to talk about the kind of electrical component, because our communication in the brain and in the body system is electrical, electrochemical. So now we're at the receptor processes, and we're going to talk about the sensory receptors. So we had that proximal stimulus, and I said it was hitting the sensory receptors. In the case of the eyes, again, I'm going to keep this simple and stay with vision. That picture of the angel tree was hitting the rods and the cones, those sensory receptors of the eyes, and they contain a visual pigment that is allowing for transduction, the transformation of one form of energy into another form of energy. So the transduction of light or electromagnetic stimulation to electrochemical energy in the case of vision. The transduction or the transformation of those changes in air pressure, the sound waves, gets transduced to electrochemical information that the brain can understand. The chemicals that we take in through our mouths and our noses, that gets changed into or transduced into electrochemical energy that the brain can understand. So the receptor processes involve this transduction, this big change. Next is neural processing. So this transmission of information from the sensory receptors to and through the brain is neural processing. If we don't get that information to the brain, we don't have any perception. So if we have something going on with our optic nerve, or if we have damage to our visual cortex in the brain, everything's going okay with the eyes, then the sensory receptors are working, but we still don't perceive the actual stimulation from the world. Neurons in the brain are also going to interact with each other in various ways, and again, depending on aspects of our subcortical structures, that neural processing can be different for each of us. So we're seeing again the principle of transformation, the principle of representation, because this processing is allowing for transmission and for change to occur. He's taken this picture out of the book, which he used to have in there for neural processing, and I think it shows up later, but I like to go ahead. I feel like the more exposures you have to something, the better off we all are. So if we talk about, as we're talking about neural processing, as I'm talking about what's happening with vision, that is, again, going through those subcortical structures, so it's really coming from the front of the brain, and it's going to hit that back part of the brain. If you look at the back part of the brain, that's kind of orange, that says occipital lobe. That's where our primary visual cortex is. For hearing, we take that information in through our ears. It goes through some subcortical structures. It goes to most of it goes to the other hemisphere, so it again crosses through the brain to the other side. Not all of it, but some. And it gets to that green area called the temporal lobes, and you can see the darker green where we have our primary auditory cortex in our temporal lobes. As we're also moving up forward from the occipital lobe, if we go up and if we go forward and dorsally up, we get to the parietal lobes. As we're feeling things on our skin, or actually in our joints moving and pain, any of that kind of stuff, we're going to feel that in the primary somatosensory cortex, that little blue strip that's in the parietal lobes. And then as we move forward into the frontal lobes from all of that, that frontal part is where we're really putting that all that information together. We don't talk about the frontal lobes a lot because we're really perceiving, and a lot of that is happening in the occipital, parietal, and temporal lobes. But we will talk about it, and we don't talk about decision making or anything, but we will talk about it when we talk about taste and smell, and putting that information together to perceive the flavor of foods. And that's happening in the very frontal part. And that dark pink strip that is the primary motor cortex, we will not talk about that at all, because in this class we are sensing and perceiving. We're not going to move very much. We might talk about it a teeny tiny bit, but we're not going to move much for this class. Okay, so we've gone through the first 4 steps, and I've added in a slide where I have all 7 steps, so I'm going to go through these again briefly. But the distal stimulus, the proximal stimulus, the sensory receptors, so the receptor processes, and then also neural processing. Okay, and step 5 is perception. And this is where we get to our experience and action part of the perceptual process. And the perception is our first conscious experience of the environment. Okay, so up to now, everything's been completely under our awareness, everything that's happened. And at this point, this is the brain's, basically the translation of incoming sensations so that we can start to understand the environment. But we want to separate that out from actually recognizing and understanding the environment. Okay, where recognition is comparing that perception with memory, potentially, categorizing it in some way, that kind of recognition. And this is an important distinction. And one of the reasons we know that this is an important distinction in our processing is because of people who have a particular brain damage that results in visual agnosia. And your author gives the example of Mr. P. So Mr. P is one of the patients of Dr. Oliver Sacks. Oliver Sacks is a wonderful writer and a neuropsychologist who writes up a lot of his case studies. And Mr. P went to Oliver Sacks. At first he noticed that he was a music professor, and he was not recognizing his students anymore. And to some extent you can understand it starting to happen as we have more and more students, and we just start to become confused maybe about who's who and get them kind of muddled. But that's not what was happening. This was a complete lack of recognition. Okay, but then sometimes when they'd start to talk, he could recognize them by their voice. And still we might think, okay, he's having problems with faces, but he's a music professor. He pays attention to his auditory stimuli, so he recognizes them by their voice. But it turns out, so one day his wife and him are walking, and he runs into a parking meter, and he tips his hat and says, "Excuse me, ma'am." Okay, and now his wife realizes that something's really quite wrong, and that's when they go to the neuropsychologist, to Dr. Sachs. And the reason for the name of the book this comes from, which is The Man Who Mistook His Wife for a Hat, the book was named after this case study, where after talking to Dr. Sachs one day, Mr. P gets up and he goes over to his wife and he starts to lift up at her head as if her head is the hat on the hat rack. So really not recognizing the world. And just one more example. So one of the tests they gave him was to show him a baseball glove, and the doctor asks him to describe it, and he says it looks like, a leather round bag with 5 outpouchings. And the doctor asks him, so what is it? And Mr. P says, "I don't know, maybe it's a purse for 5 different sized coins." So really not putting together that perceptual information with memory for objects and being to recognize these objects. And again, this is because the damage to the brain is higher up in cortical processing. And then step 7 is the action, or what do you do with the information? And Goldstein, in previous books, he had a diagram that then pointed from the action back to the distal stimulus, because what we do with that information can possibly change the distal stimulus and possibly change the proximal stimulus. So if I see a butterfly on the angel tree and I start to walk up to it, then really that distal stimulus is changing, and the proximal stimulus is changing as I'm getting closer to a particular branch and to the butterfly itself. So every time I move my eyes, what's hitting my photoreceptors is changing. So it is a really cyclical process. I put these up there, so just to go through them one more time all together, because I think sometimes students aren't realizing what I'm talking about when I'm saying the perceptual process. These 7 steps, starting with the distal stimulus, so what's actually out in the environment. In this case for us, it's a picture of the angel tree. The proximal stimulus, that when you're looking at that, we have an image of that flipped and upside down. So upside down and transverse on our back of our eye, hitting our photoreceptors. We've already gone through transformation. We're already at a point where we're representing the tree in some way. It's not the actual tree. Step 3 is the sensory receptors, or receptor processes, where we see more transformation and change. It goes through neural processing as we get through the brain, and then perception as we get to our kind of first cortical processing and perceiving the world and our conscious experience. And then separated out from perception, it's important to realize, is recognition, where we recognize that this is, in this case, an oak tree, or even just saying, yes, I know it's a tree, okay, categorizing that in some way. And then action. What do I do with that? I can walk away. I can go. Sometimes I have students say on their exams, I can go hug a tree. Okay. And just as we did that really short exercise in class or online virtually, but I want to remind you here, and I'm not going to do this nearly enough for my tastes, but I want to remind you here to really bring awareness to your perceptual processes. As we're talking about vision, it's not just about noticing your vision and potentially applying these concepts, although once you start thinking about how much processing and consideration of past experience and all of that is going into just recognizing our visual world. It's really quite amazing. And but really what I'm looking for is for you to think about really appreciating the visual world. And I think during the fall, it's really fun to go out and notice the changing of the colors of the leaves. But maybe you have some nice videos or movies that have some real visual contrasts that are interesting as well. So maybe just bring some awareness to all of that. And at first we'll talk about vision, but all of your perceptual processes. So hearing, smell, taste, feeling that the touch on your arms or cold or heat or pain. Of course, it's hard not to be aware of pain when you have it, but just think about being aware of it and adding some appreciation to that.